So in this next video, what we're going to do is use our knowledge of oxidation states now to show how they'd be used in names. And you've come across this briefly in some of our other packs before. So the first job I want you to do is just look at that first table and using the rules from the previous video, see if you can assign the oxidation state to the metal. Now remembering that the metal, we've got Fe here, copper here. So what's the oxidation state? Just pause the video and work out the oxidation state. So if you've done this correctly, you should have got +2, +3, +1 and +2. So how does that bear into the name? Well, it's the ion that has that oxidation state. So we're going to use Roman numerals, and the Roman numeral for 2 is II. It's ion in oxidation state 2, and then it's an oxide, so the negative ion name. The next one would be ion 3, which is III, oxide. And we've got copper 1, oxide, and copper 2, oxide. So putting Roman numerals in, and the Roman numeral comes after the metal because it refers to the metal. We don't need a Roman numeral for oxide because oxygen is always -2. Okay, so let's have a look at these different acids. First thing I want you to do is tell me the oxidation state of, it says the non-metal, but they're all non-metals. I want it of the sulfur, that's the variable one, or the nitrogen. So pause the video and work out those oxidation states. If you've done that correctly, you should have got these. Now, it's the name of this top one. You would have always just been happy to tell me it's called sulfuric acid, but there's 2 types of sulfuric acid, and this one is called sulfuric 6 because the oxidation state is a 6, and that's Vi. So what would the next one be called? Well, the next one would be called sulfuric, and then IV for 4. So see if you can name the bottom 2. And you should have got nitric acid for both of them, but the first one is nitric 5 and the second one is nitric 3. So when these acids are then used to make salts, the name of the salt will reflect the name of the acid. So again, I want you to work out the oxidation state of the important non-metal there, so the sulfurs and the nitrogens. Pause the video and have a go. So you should have got a +6 for the first one, and you would have normally just told me that's called sodium sulfate, and I would have understood what you meant. But we do need to also bear in mind that there could be 2 types of sodium sulfate. There could be another sodium sulfate that would look like this, Na2SO3. Now, how would I know if you just told me sodium sulfate which one? Well, the oxidation state of the sulfur, so the Roman numeral is going to come after the word for sulfur, is a 6. So sodium sulfate, and it's the sulfur. I know it's not the 8 because I know that oxygen's always -2. So this ion that's in sodium sulfate 6 is called the sulfate 6 ion. And if I had the ion from this sulfate, this is SO3 2-, this would be called the sulfate 4 ion. And then I've got nitrate 5 in my, so that's actually not my full answer, is it? Because I've missed out the sodium nitrate 5 and then the nitrate 5 ion. And again, we could have used the NO2 from the top table with the nitric 3 acid, and we would have made NaNO2, that would be sodium nitrate 3. So let's work it the other way around. If we're given the name, can we get the formula? Now, there are some things that it's really helpful to remember. To remember that all nitrates, chlorates and iodates are -1. Now, I think nitrates is the one that is harder to remember. I always think, well, chlorides and iodides are -1 because they're in group 7, so chlorates and iodates are -1. Sulfur is in group 6 and sulfates are -2. Phosphor's in group 5 and phosphates are -3. It's just nitrates that seems out of position a little bit. But we already know the formula of nitric acid is HNO3, so we should be able to remember our nitrates are -1. So how would you put all this into practice? So it says, give the formula of sodium chlorate 3. So we know that sodium is always +1. So we know that that bit is Na+, it's always +1. Okay. Chlorate 3 means that it comes, chlor means chlorine, and 8 means oxygen, and we know that chlorates are always -1. So we know we've got chlorine and oxygen, and chlorates have a -1 overall charge. And it's telling us chlorate 3, which means we're going to put a +3 here. We know that oxygen is -2, and that these two have to add up to the charge. So how many oxygens do we need to get 3, take away 2, but we can add more oxygens if we need them to get to -1. Well, if we have an extra oxygen, so 2 altogether, we will get a charge overall of -1, and chlorates have to be -1. So our formula is Na and then ClO2. Now we're putting them together because we know that if we've got an Na plus and a ClO2 with a 1- charge, that they will balance out. I'm going to skip a couple here to go to a slightly trickier one. I'm going to go to sodium sulfate 4, and I'm going to think through our processes. So we know that sodium is Na plus. We know that sulfate is made of sulfur and oxygen, and sulfates always have a -2 charge. Now if it's going to be a 4, this is a +4, how many oxygens do you need to add in order to get to -2? So remember that each oxygen counts as -2, so 4 take away how much is -2? Well, I need to -6, which is the equivalent of 3 oxygens, and so the sulfate 4 ion is an SO3 2- ion. So now I know my 2 ions, but how do I put those together into an ionic formula? Well, I've got to balance the charge. So to balance a 2- I need 2 pluses, so I need 2 sodiums and a sulfate 4. Let's have a go. You pause the video and see if you can do these other examples. So chromium 3 means Cr3+, because it's not one of our fixed ones, and oxygen is always -2, so that's O2-. And then I just balance out the ions to make a formula that works. So potassium is K+, but sulfate 6 means that the S is +6, so we'll need 4 oxygens to get to -2, all sulfates are -2. And then to balance that, it's going to be K2SO4. So our nitrate 3 must be an NO2 1- ion. And magnesium is an Mg2+, so I'm going to need 2 of these nitrate ions to balance the magnesium, and we end up with that. So chlorates are always -1, and the chlorate 5 means that the chlorine is +5. How many oxygens to get from +5 to -1? We need 3, and then because there's a 1+ ion and a 1- ion, it's just going to put them together, KClO3.